Hello, everyone. Thank you for your time. My name is Daniel, and I'm here with Team Archimedes, and we would like to present our solution for company Siemens. Let's start with our customer. This is Mirek. Mirek works at this big Siemens manufacturing plant. Uh, he uh, he really does only one thing. He is responsible for the spare part management at this plant. And the biggest questions he asks himself every single month is how many spare parts do we need to order for the next month? He has gained a lot of experience during his work there, but still, he thinks that they store way more spare parts than they should have, and that number could be reduced. But here it doesn't have any kind of concrete evidence of it, so that's exactly why we came to work on this project. Siemens came to us with those specific problems. They think that they store way more spare parts than they should have, and also they really don't have any kind of tool that could help them with the decision making when ordering new parts for the next time period. The last problem would be that they really cannot predict the amount of spare parts they need in terms of future demand, which they have planned for another 3 years through the capacity plans. So our solution, how did we actually try to solve this? We came up with our own application that allows users to select spare part they want to order, and then they get the prediction of how many spare parts they need to order for the next month. How does this actually, how does this actually work? For this, we use predictive model that takes data, the provided data, and we transform those data and also pre-processed, and then put it all into one simple Streamlit UI that allows user to see the prediction and other important indicators, which could, in the long run, help them with the better warehouse management and also with the cost reduction. Our application prototype was presented to the company by Siemens, and they are pretty happy with it, and they are open to the implementation of this project into their production environment, their production systems. But as I said before, it is only the prototype. That means that the UI and also model itself needs to be improved over time by getting more reliable data and more user feedback. That brings us to the business value of this whole project. Based on the estimates made by Siemens, we are expecting 10 to 20% of decrease of inventory costs if Mirek's theory is correct.
Of course, it's also important to note that the capital is tied up in the spare parts that are not used, and the capital freed is also very important for the company. Now, so what are the insights that we have reached at the end of the project? Now, records with missing assigned workplace. Obviously, the granularity of the data, the assignment, they imagined that we could predict exactly not just the amount of spare part used, but also where it will be used precisely. Now, as we discovered in the data, this was not always possible. Only 15% of the transactions were recorded properly, and therefore that limited us a lot with the granularity we were able to achieve. So eventually we could only predict the usage for the whole plant. Is inconsistency with the IDs. We have discovered in the data, and then the Siemens confirmed that a lot of the materials IDs has been changed at some point, and that made it a lot more difficult to just use all the data and connect the correct dots. That's why at this point a lot of the data that is unused, and for in the future that's something that could be worked on. Yes, the less spare parts usage. Much less spare parts were used than Siemens anticipated. Overall, our final data set that was used for training had around 6,000 different entries. Out of those 6,000 entries, they contained the data about 500 materials. So even the most frequent ones, the usage wasn't that, it didn't happen that often because the data contained 11 years. So some of the data had only one record of usage in the last 11 years, and data like that is unpredictable from our point of view. So we have eventually narrowed it down to limit, we only try to predict the materials that had at least 50 different records, and we only managed to get to 20 different materials that were fine with this. Yes, and the granularity reduction I kind of mentioned, but there was a big problem with the data. There was some undesired patterns in the data that we had to solve, and that is that when the data is put out of the stock to be used, they tend to often take out the same amounts, which means the data has to be predicted not just on the one transaction, but it has to be predicted in how much spare parts is used in a month, which means the data had to be transferred from cross-sectional to time series data for the predictions to make sense. Now, what is the roadmap from this point to the future? First, there is the implementation. At the current state, the application is using the CSV, which is uploaded to it, and this data is used. This in the implementation, it's best if the data pump is created and this data is periodically renewed. We didn't have the option to do it because we didn't have the access to their company systems. Now the testing, of course, you run some real predictions and then you compare the results to actual usage of the spare parts. Of course, some bugs could also be fixed in this state, some bugs that we didn't manage to somehow fix up until this point. Then the production, slowly a new lower boundary has to be set for the amount of spare parts that is in the warehouse. Once this, and then the company stops ordering spare parts. Once this lower boundary for the wanted predicted material is reached, then the model is ran and the predicted amount of spare parts is ordered. Expanding the model, of course, during the time we didn't manage, because of the data quality, we didn't manage to fully implement all the data that we wanted, especially the capacity plans, which are important, but there was just not enough data. And this is tied to it. During the time, now they know what data we need into the model, and what data will, if they collect the data in the higher quality during the time, then the model will improve on its own, because the more data is always better. Thank you for your attention, and now we will take questions.
So thank you for your presentation. Now you are obviously bored of Siemens.
Okay, I got one question. Have you considered even a time there, since your prediction will tell you, well, you will run out of your parts, then can it give you some kind of estimate, tell you, hey, you will run out of parts in 2 days, let's order them and they will be delivered, for example, in 1 day. Have you considered even these timelines there?
These timelines haven't been considered at this point. We had to narrow down the focus a lot because of the data quality was a big limitation for us. So originally we wanted it to be able, the model to predict the zero values as well. We didn't manage to get there. So at this stage, what the model simply does is this new lower boundary has to be set by them. We didn't have direct access to their storage full. We just had access to transactions, the movements in the warehouse. So at this stage, the way it works is just, yeah.
I would say when this is implemented into production, then we get access to like all the data, even like the how long does it take to deliver the material, and that would be something that would be part of the roadmap, and like we should implement it in like the future.
Okay.
But right now it's not really
Once
possible.
you got the access to the data, it makes sense.
Yeah.
Okay. Thanks.
I would like to ask you, it was like in between the lines, but what is the cost for us of not doing this and using some alternative solutions, some of those like suboptimal solutions? And then depending on that answer, how fast can we have this fully implemented? So we saw the roadmap. What are your like estimates?
Well, since we have a limited information from the Siemens, it's really difficult. But I would have well, the implementation itself shouldn't be that difficult. But of course, it has to be tested with the result. So probably. It would get into production for the most valuable materials that were most predictable for us. I think in a couple of months earliest, because there needs to be done still elaborate testing on the live, of course, the live usage.
Okay, this prediction model now is prepared for only one case. As you know, we have many subsidiaries. We can use it for maybe some other cases. It's like, is it option to use it for some another case, not just this specific one, or it's prepared that it's working only with this type of data?
The model itself is it's just an algorithm applied to the data that we put in, and it's trained specifically for that data. So the only thing that would be like transferable to other things is the concept of how you do it, but you need to transform the new data, which is totally different for other usages. You need to again pre-process this in a way that it makes sense, and the whole process of creating it would be separate.
Okay, and you mentioned there were many errors in the testing phase. They are fixed, or
well, I wouldn't say errors. So what I would say is there were a lot of difficulties in the data, as I mentioned, especially the granularity of it. They wanted to know when they predict exactly where, like, they wanted us to predict where exactly the spare part would be used, like the work site, the specific machine. We couldn't do that because there was just not all the data had it. And already as it was, we didn't have a lot of data. The 6,000 is not a lot for training a model that has multiple materials, because the model is, he's creating a separate prediction for a separate material, and 6,000 it's nothing. If you compare it to some bigger machine learning models, they use millions.
okay, and did you give some recommendation to achieve in this model?
Well, the best recommendation is just keep collecting high quality data, and well, over time the model will improve. And also they wanted us originally to include the capacity required, which means of course it matters a lot how much the machine is going to work for us to know how quickly the spare parts are going to be used. But we just had so few data that there was no chance to implement it for the model to actually have better results than it does now.
Okay, thank you.
Thank you for your presentation.
Thank you.